Good evening. Going to start talking about least common multiple now instead of greatest common factor. So these can easily be confused, although they're very, very different. So one of the reasons we're learning how to find least common multiples is in order to add or subtract fractions, I've written it right here, with different denominators, you have to learn how to find a least common denominator. Well, finding the least common multiple between two numbers is the step before the skill of finding a least common denominator. So we need to be super clear on the difference between these terms, factor and multiple. We've been doing a lot of talk about factors. So if we want to know what the factors of 12 are, the factors of 12 are all the numbers that divide into 12. The factors of 12 we've listed underneath there, 1, 2, 3, 4, 6, and 12. Factors are a finite set, meaning you can count them up. There's an end. It does not go on infinitely. Multiples, on the other hand, are very, very different. Multiples of 12 are values that 12 divides into, not that go into 12. There's a very big difference in how you say that. Some of the multiples of 12 are the result of 12 times 1, 12 times 2, 24, 12 times 3, 36, 12 times 4, 48, 12 times 5, 60, and so on. Multiples are what we call an infinite set, meaning you can't count up all the members. It goes on infinitely. By continuing to multiply 12 times the next integer, you would produce more multiples. Well, while we were interested in finding the greatest common factor, now we're interested in finding the least common multiple. So it's the smallest value that is a common multiple of two or more numbers. In other words, it's just the smallest number that two or more numbers divide into evenly. That's probably the best way to remember it. And okay, I don't know where my highlighter went, so we will not highlight it. So smallest number that two or more numbers divide into evenly is how I would remember it. Okay, so just gave a couple of simple examples. The least common multiple of 2 and 10 is 10. Remember, the greatest common factor would be 2. That's the biggest number that divides into 2 and 10, but we want the number that 2 and 10 divide into. So remember, the LCM can't be any smaller than the largest number. Otherwise, the largest number won't divide into it. So the least common multiple of 4 and 6 is 12. Notice up here, one of the numbers, you had two numbers, 2 and 10, and the LCM was 10, which was actually one of the numbers. But sometimes that's not the case, like for 4 and 6. 4 divides into 12, 6 divides into 12, so the LCM is 12. Well, 4 and 6 both divide into 24 as well, so we would say 24 is a common multiple, but it's not the least common multiple. So some of them, as we did with the greatest common factor, are very easy to find mentally if you know your multiplication facts. So do it mentally when you can, if not otherwise direct it. I will be directing you on the homework to actually show support. So you're going to be finding the LCM today in 3.5a using prime factorization. Which is a previous skill. One method that some students and teachers like to use is called the listing method. And I've listed some of the disadvantages of that. This method can be just lengthy. It's not challenging really, it's just kind of tedious to do. It's easy to make an error, and it's just not an efficient use of your time. Done an example down here. Find the LCM of 10 and 15 by listing. So I just listed a few multiples of 10, 10, 20, 30. And then when I list the first three multiples of 15, 15, once I get to 30, I notice, okay, they both have 30. It's the smallest one, so the LCM is 30. So you can see one of the advantages is it's very straightforward. It's very easy to see why that's the smallest number that 10 and 15 both divide into evenly. Well, working a problem two different ways is a good way to confirm your answer. So you could feel free to use the listing method as a way for checking your LCM when you're finding it another way. But for assessment purposes, we're going to focus on prime factorization, and then the next section we'll talk about the ladder method some more. Well, I've already mentioned that sometimes you can see it pretty easily, but let's look at some prime factorization. Now, you already know how to use a factor tree, or you could still use the ladder diagram to do prime factorization. But the LCM we're looking for of 12 and 32. So you get this far, just like we did before. So I'll just circle all my primes. We just kept breaking down each number until we only had primes. So I wrote it out in non-exponential form first. We had 3 2s, 4, 5 5 2s to get 32, and then 2 2s and a 3. So we're not going to write it that way. We're going to write it in exponential form instead. So just like we did when we were working on greatest common factor. So 32 would be 2 to the 5th, 12 would be 2 to the 2nd, times 3. Well, you might remember when we were looking for greatest common factor, we looked for the least power that they had in common. Well, now we're looking for the highest power that they have in common. The highest power of 2 and the highest power of 3, because they have both 2 and 3 in common. And then we multiply, oops, let me get off the highlighter there, don't I? Let's go back. Then we multiply all of those together. So you compare 2 to the 2nd, 2 to the 5th, and you want the highest 2 to the 5th times 3. The reason you want the highest is because 12 to the 2nd will fit inside of 2 to the 5th, but 2 to the 5th won't fit inside of 12. That's why you need the highest power. There was only a 3 to the first power, so we use it. So 32 times 3 gives us 96. You really have to concentrate in order to switch gears from doing what we did before with greatest common factor. So now you're looking for the highest power they have in common, not the least. So for 56 and 70, let's work it out. 56, let's see, we could start with 8 and 7. 7's prime. 8 would be 4 times 2. 2 is prime. And we'll break down the 4. So I'm going to come over here to the side and write out 56 is equal to 1, 2, 3, 2 to the 3rd times 7. 70, I think I'll start with 10 times 7. 7's prime. 10 breaks down into 2 and 5, both prime. So come over to the side. Prime factorization, keep writing that in order like we did before. Underneath, LCM. Remember, now you're looking for the highest power of factors that actually need the highest power of each of the factors. I think earlier I said common. That's actually incorrect. I need to adjust that on my notes. So you look at the 2's, and you need the biggest one. So that's 2 to the third. This one has a 5, and this one doesn't. Well, I have to include 5. If I don't include 5, then this number 70 won't divide into it. And then they both have a 7 in common, so the highest power of 7 is 7 to the first. So that's 8 times 5 times 7. That's 40 times 7, which is 280. Let's scroll back to our previous notes, back a little further to the... Well, actually, I didn't write that. I just said use the highest power. I'm just double checking what I wrote. Let's go back one more. Okay, well maybe I have not messed it up. That's good. That's good. Let's try another one. 48 and 36. Now, don't be, if you're thinking 12, that means you're thinking GCF instead of LCM. Remember, GCFs divide into the number. We're looking for the smallest number that 48 goes into and also 36. So 48, 36, doing our prime factorization. So I might start with 6 times 8. Neither is prime. So break both of those down. This would be 2 times 4, and 4 becomes 2 times 2. All right. Let me do 36 in a different color. 36, I think I'd start with 6 and 6. Then just break each one down into 2 and 3. All right, so over to the side or underneath. I would write underneath if I had room. That's better to work down. But if I write over here, I could say, well, 48 equals 1, 2, 3, 4 2's. So that's 2 to the 4th times 3. And 36 is 2 2's and 2 3's. So 2 squared times 3 squared. So the LCM is going to be the largest power of each factor. So the largest power would be, for 2, would be 2 to the 4th, and for 3 would be 3 to the 2nd. So that's 16 times 9, and that is 144. If you don't know that that's 144, of course you would just do a little scratch work out to the side. This is really the expectation, the prime factorization for each number. Write it out. Show what you're multiplying to produce the LCM. You would not just stop. Let's make a note here. Don't stop with the factor trees. I'm going to put slash here, ladder diagram. Don't get ladder diagram mixed up with the ladder method that we used for GCF. They're actually quite different. Don't stop there. You have to go and do this, this, and this. Okay? Well, that's the end of our examples. So good luck, and the next video you're going to watch, you'll be learning about how to do the same thing, but just a different method. Good night.